A very good morning to all my dear 10th class students and welcome back. I'm back again with the few very important concepts from this chapter, periodic classification of elements, children. As you know that we have been learning few concepts from the long form of periodic table. In my previous videos, I gave you an introduction and just a few points regarding the long form of periodic table. Today we will learn how it emerged as an advanced or what you call more accurate way of classifying the elements. As you know that previously many scientists actually gave many attempts where they attempted to classify elements based on the atomic mass, which was not successful. What made this long form of periodic table successful? It's the fact that the criteria for the classification of elements here is not the atomic mass in particular, but the atomic number as suggested by Henry Moseley. So that brings about, it brought about the accurate way of classifying these elements, and all of the anomalies which the previous laws or the classifications had, they were actually explained very well. So let us see how this long form of periodic table gave an explanation. It gives an explanation of the limitations or shortcomings of the previously told models or what you call laws. You can see that the position of isotopes was not given properly by Mendeleev. He could not explain why the isotopes have to be given only one block. Because isotopes, what are isotopes? These are the elements, okay? These are the elements which have the same atomic number but different mass number. As you know that a substance, any element is represented like this. Here we have the atomic number written and on top we write the mass number. So all those elements which have the same atomic number but different mass numbers, they are called as isotopes. So when the moment I say same atomic number, it refers to the same element, right? For example, carbon, if you take, it exists in two forms in nature, C12 isotope and C14 isotope. That means the atomic number of carbon is 6. Atomic number of carbon is 6, but in one case, the mass number is 12, and in another, the mass number is 14, and that is due to the presence of two extra neutrons that gave rise to this difference in this mass number. So both are carbons only. When both are carbons, they should be like because of the difference in the atomic mass, they are given they should be, according to Mendeleev, they should be given a different position in the classification, in the table, right? Because they have different mass. So that he could not explain. Now the fact is how this long form of periodic table gave an explanation of the isotopes is we are considering the atomic number now. So the number, Niels Bohr prepared this periodic table, and according to the suggestions made by Henry Moseley, he took into consideration now the atomic number. So the atomic number is same, so all the isotopes of different elements, they can be put in a single place, in a single block. So that rules out, what you call that overcomes the problem of position of isotopes here. Now position of iron, cobalt and nickel. As you can see that in the Mendeleev's classification, there was a slight misarrangement of the positions of iron, cobalt, nickel according to Mendeleev's actually. Nickel having slightly lower atomic mass has to be actually kept in the middle. That is nothing but before cobalt actually. But it was placed like this and he could not give any explanation. Now for the fact that cobalt and nickel, if you talk about this order, will be fine if you consider the atomic number again. So if you go according to the atomic numbers, cobalt should come before nickel and nickel should go afterwards. Like after this cobalt, nickel should be placed. And this explanation also Mendeleev could not give. So when you take atomic number into consideration, all these actually limitations or anomalies, they are solved, or nice explanation is given to these. Position of hydrogen also, children. Like we know that hydrogen has got this nature, the characteristic properties of both. It is more like the metals and also like what you call, and also like the halogens, salt producers and all. Halo means salt and gen means producer, children. So it has certain characteristics which are similar to that of both the group 1 elements as well as the group 17, nothing but the halogens. So he could not actually, Mendeleev placed hydrogen in the group 1 elements only, and he could not give a proper place to hydrogen. But in the modern periodic table, now we have a separate place as hydrogen is a special element, and it is given a separate place above the group 1 elements. So all these anomalies were answered very nicely, and they were overcome by the long form of periodic table. So hope you understood this. Please, if you don't understand, repeat and try to frame answers on your own. Just pose questions on your own, like like I can ask, like, what are the different anomalies of Mendeleev's which were overcome by the long form of periodic tables. Here you have to write the anomalies of Mendeleev's and the explanation how it is overcome or explained by the long form of periodic table. Now we'll discuss about the characteristics of periods. Actually, certain characteristics, how they change in a period. What is period? It's nothing but a horizontal row. So we have such 7 rows, periods, in the long form of periodic table, right? So certain characteristics, they change as you go from left to right in a period. As you move from left to right in a period, we see certain changes, like a gradation of the characteristic properties. How the different characteristics change, we'll be learning now, children. Okay.